You know, Vestas is just this absolute giant in wind energy. We see their turbines everywhere, all over the world, but do we ever really stop and think about what it takes to run an operation on that scale? Okay, let's really get into it. We're going to start with the massive big picture view and then zoom all the way down to the tiniest detail.
So get this, the company has put over 193 gigawatts of wind power out into the world. That is just a staggering number. I mean, to put that into perspective, that's enough juice to power tens of millions of homes. It's a truly colossal footprint on the global energy map.
And that power, it's spread out across 88 different countries. Vestas has installed more capacity than anyone, and I mean anyone else in the entire wind industry. They are, no question about it, the market leader, managing this enormous fleet of over 50,000 turbines.
But that just brings up this fascinating question, right? How in the world do you manage all of that? How does a big corporate promise of global power and reliability actually happen? What's it like day to day inside one of these giant machines?
Well, the answer isn't in some slick marketing brochure. Nope, it's in documents just like this one. This is the mechanical operating and maintenance manual for one specific, very powerful turbine model, the V90 3.0 megawatt. This is where those big promises meet cold, hard reality.
So let's dig into this rulebook, because this is so much more than just a bunch of technical jargon. Think of it as a guide to operating in this world of incredibly high stakes, where pretty much every single action is governed by extreme caution.
And the manual makes it crystal clear right from the jump. The responsibility is just immense, and it all falls on the shoulders of highly qualified people. These are not machines you just flip a switch on and walk away from.
In fact, the risks are so real that nobody is ever allowed to work alone. For any procedure, doesn't matter how small, at least 2 people have to be there. I mean, that one rule alone tells you everything you need to know about the potential dangers when you're working hundreds of feet up in the air.
And, when things go wrong, you absolutely need a way to stop everything instantly. And that brings us to one of the most critical safety features inside the nacelle. That's the main housing at the very top, the emergency stop buttons. Now, as you look at this layout of the nacelle, the box that holds all the important stuff, you can see these emergency stops are not an afterthought at all. They are very deliberately, strategically placed all throughout the structure.
I mean, they're everywhere. You'll find one at the ground controller before you even go up the tower, another one on the massive gearbox, one near the yaw ring that turns the whole nacelle, one at the main controller, and even one up in the nose cone. The point is, no matter where a technician is, a complete shutdown is always just an arm's reach away.
And here's what that actually looks like. On the left, you've got the diagram, showing where that button is near the yaw ring. And then on the right, that's the real deal. The actual button in its real-world environment. Right there, totally accessible, totally unmistakable.
Let's look at another one. Here it is on the diagram, right on the gearbox. And bam, here it is in reality, mounted directly onto that massive piece of machinery. There is absolutely no ambiguity.
So what's the bottom line here? It's simple. You press one of these big red buttons and it triggers a total system shutdown. The blades immediately pitch so they stop catching wind, the main brake slams on, and every single moving part of this powerful machine grinds to a complete halt.
But, okay, an emergency stop is one thing. What if you need to do planned maintenance? You can't just count on a temporary brake. You have to mechanically lock down a rotor that weighs tons and tons. And believe me, that requires a whole other level of procedure.
Turns out there are 2 ways to do this. For your sort of everyday normal service, there's a hydraulic rotor lock. But for anything more serious, like if it needs to be shut down for more than 2 days or for major repairs, you need to physically bolt the rotor down.
And even the simple hydraulic lock requires this incredible precision. A technician has to use the brake to line up this little V-notch marking on the massive spinning hub with a tiny pointer before they can even start to pump the locking mandrels into place with a hand pump.
So, that's the everyday procedure. But for the really big jobs, when that machine needs to be absolutely, positively 100% immobile for days at a time, that hydraulic system just isn't going to cut it. You have to break out the heavy hardware.
And this is that hardware. Just look at this list for a second. We are talking about massive M42 bolts, special nuts, shims, mandrels, and, get this, 128 special M16 bolts. This is some serious, heavy-duty mechanical engineering.
But really, it's this diagram that just shows the unbelievable level of detail required. You don't just tighten the bolts. No way. You have to follow this super precise circular sequence, tightening them first to 70 newton meters, then you go all the way around again and tighten them to 140 newton meters, and then you go back and recheck the first 3 just to be sure. Every single step is laid out.
And this, right here, brings us full circle. We're zooming back out now, connecting this one tiny, hyper-specific procedure to the company's big global promises. You go to their website, and Vestas talks all about reliability, consistency, and predictability. They talk about creating the best, most powerful products to deliver efficient solutions. You know, it's that kind of high-level language every big company uses.
But after everything we've just seen, we now know what that language actually looks like in the real world.
See, on one hand, you've got the big promise, maximizing your profits. And on the other, you have the actual procedure that makes that possible. Tighten the 8 M16 bolts to 70 newtons. The certainty of that global investment is built quite literally one carefully torqued bolt at a time. The power and quality of the product is guaranteed by the absolute rigor of the process.
And that just leaves us with a final thought to chew on. We've just taken a tiny peek inside the rulebook for one machine. So if this is the incredible level of precision and caution it takes to operate a single turbine, what on earth does it take to manage a fleet of 50,000 of them, scattered across 88 countries, day in and day out?